Hello everyone, welcome back to another video. Today we're going to be talking about a super exciting topic, and that's going to be how we can write a KNN from scratch. So that's what we're going to be reviewing in today's video. I'm going to go through a comprehensive tutorial of all the concepts, talk about how KNN works, what it is, and how we can implement it in code. Let's get right into it. Alright, so let's talk about k nearest neighbors, how it works, and the ins and outs of the algorithm. Okay, so let's say you had a graph. The y-axis was salary of a consumer, and the age was the age of some consumer. And we're trying to look at this data and identify the patterns in the data. An example would be what consumers bought some product versus what consumers did not buy that product. So the goal of KNN is to be able to group data based on some target variable. And the target variable we're going to be talking about today is binary, which means it has two options. Specifically in this data, it's going to be whether a consumer bought a product or whether they did not buy a product. So how can k nearest neighbors be used to solve this pattern identification problem? So let's say we identified that the left group of data points were people that didn't purchase the iPhone, and the right group of data points were people who did purchase the iPhone. If we introduce this point, what class would this point belong to? Here's how k nearest neighbors is used. So k nearest neighbors algorithm measures the distance from our tester data point to the nearest neighbors, and that nearest neighbors value we'll set as 5 for now. So we measure the n closest neighbors, in this case it's 5, so we measure the 5 closest neighbors, and we identify what are their labels. In this case, 3 of the labels of the neighbors are 0, which means 3 of the neighbors did not purchase the iPhone, and 2 of the neighbors did purchase the iPhone. So now what do? Now we take a majority vote, and based on the result of the majority vote, we label our tester point. So we see that the majority is 0, so we label the point part of the 0 class. And that's how KNN works. So we are going to write the KNN algorithm from scratch. So I suggest you guys go to kaggle.com so you can follow along and code right next to me. Let's get into the code. So if you're familiar with the channel, the first thing we usually do is import the libraries and dependencies. Now if you watched the previous video about KNN algorithms that I'll link up here, you'll notice that we're using the same dataset. What I want to do in this video is prove to you, someone who's interested in learning about AI and machine learning, that it is possible to take any algorithm and write it from scratch. The code might be longer, maybe a little bit more convoluted, but it's possible to create algorithms without using libraries like scikit-learn, TensorFlow, and Keras. So here are the libraries we are going to import. First, we're going to import NumPy. This is going to be for mathematical calculations, arrays, things of that nature. Then we're going to import pandas. This is going to be for our data structures and such. For visualization, we're going to import matplotlib. And notice how we're using this as identifier to shorten the calls of these libraries. We're also going to import Seaborn for EDA, exploratory data analysis. And then we're going to use scikit-learn, but not for the algorithm, for actually just train test split and accuracy score. All right. So we're not actually using this for the algorithm. We're just doing this to get the accuracy and also just split our data up into training and testing. This can also be done for Scratch, but just for the purpose of beginners, I chose not to do this from Scratch in this video. Alright, so we have train test split, and I'll explain what both of these mean. And finally, we need from SciPy stats, the mode function. Alright, so those are all of our dependencies imported. So we're good. Just to get the draft session started, when you're first in Kaggle, it will say draft session off. So you just have to press this play button. It will start the draft session, and then from there, you'll be able to run your code without waiting a long time. But the first time you run the cell, it might take a little bit of time. So now our job is to import our data. All right, so to import our data, we need to go to the right side and press the Add Data button, and this is going to pop up, and it's going to give you a bunch of data sets that Kaggle already has, but we're using an external data set. So you need to go to Upload, and then this is our data set. It will be linked down below in the description. We're going to press Download, and then we have the file, and then all we need to do is just drag and drop, and we can name it something. We'll call it iPhone Dataset 2021. All right. So as it's processing our data, here we go. All right, so it's processed our data. Now, we need to import this data. We need to take this data and put it in our environment, and then take a look at what it actually means. Remember, we looked at the age, salary, and it also has that whether the consumer purchased the iPhone or not. So we're going to look at what our data looks like and just ensure that we can play with it within this environment. So to import a CSV, you need to create a variable called dataset or whatever you want. I'll actually call it, dataset is fine. And then on the right here, this little object called iPhone dataset, you need to press it, and then you're going to get a drop down, and that will be where the CSV file is. You need to simply press the copy file path button, and then you need to use a pandas function called pd.readcsv, and then put the file path within the parentheses, and that way you have imported your data. How can we know that we've imported our data? If we say dataset.head, we'll be able to see the first 5 lines of our data, and indeed that's what we see, the first 5 lines of our data. But wait, we have a bit of a problem here. This gender column complicates our KNN problem, and so for the sake of today's video, we're going to eliminate the gender column because it would complicate the problem, giving us a 4-dimensional KNN problem, which is something we can't really deal with from scratch without a bunch of really complex code. So for the sake of this video, we're going to drop that column, and the way you drop a column is you create a new variable called data, well, it's the same variable, and you say dataset.drop, and you're going to drop the gender column. And then you just need a location argument axis equals 1, all right? And once you've done this, the gender column is no longer there. So make a new cell, and we will actually take a look at our data set and make sure that the gender column isn't there. And there we go. Gender column does not exist here anymore, okay? So now, we've dropped the gender column. Our data looks good, it looks clean. We have everything imported. Now it's time to take a look at what the data looks like, play with it, and then write our algorithm. All right, so this is the exciting stuff. Okay. So we need to define our x and y variables. This is super important. Defining x and y variables, how we're going to input stuff into the algorithm, all depends on what our x and y is. All right, so our x is not just age. It's age and salary, because our target variable isn't salary, it's purchase iPhone. So we have the age of the consumer, the salary of the consumer, and then the color of the dot is really our Y. What we discussed before, the blue and orange dots, all right? The people who didn't purchase the iPhone versus the people who did purchase the iPhone, all right? So our x, we can leverage the same drop we used to drop gender to reference our x. We need to drop the purchase iPhone column. But this doesn't mean we're eliminating it from our data set. No, it just means it's going to be omitted from the x variable. All right, so dataset.drop purchase iPhone means x is going to equal the age and salary columns. And then our y is just going to equal dataset, the column purchase iPhone. All right, and that's that. We've defined our x's and y's. All right, and if we print x, for example, that's what we're going to get. And if we're going to print y, we're just going to get, you know, this binary output 0, 1, 0, 0, 0. Okay. So now we have our x's and our y's. Let's visualize what our data looks like. And if you guys have any questions, errors, or just general questions, leave them in the comments down below. I would love to answer them. So now we're going to be leveraging Seaborn. Seaborn is a visualization library we imported at the very beginning. Now Seaborn is really useful for visualizations like distributions, and that's what we're going to be using it for today. So let's look at the distribution of salary as it relates to who purchased the iPhone versus who did not purchase the iPhone. And the way we do a distribution plot in Seaborn is we say Seaborn or SNS dot displot, and we have a couple of arguments. First, we have our dataset argument. Then we have our x variable that we're looking at the distribution of. And then the hue, the color of the bars, is going to be whether the consumer did or did not purchase the iPhone. All right. This is going to output a distribution graph that looks like this. How cool is this? This is a distribution of, based on salary, who purchased the iPhone and who didn't. Now, if you look at the general trends in this graph, we can see that generally, as salary increases, the number of people who didn't purchase the iPhone goes down, and the number of people who purchased the iPhone goes up. Now, there on this left side, you can see a couple of stupid people who, regardless of their salary, bought iPhones. Maybe not the best decision, but we see this general trend, all right? So we should be able to see this trend in both the visualization of our training data and the visualization of the algorithm's output with the testing data. Okay. So now it's time to actually get into the ins and outs of the algorithm, all right? So let's do that. All right, guys, so as we previously discussed, the way k-nearest neighbors works is you throw in some tester point into the data, and you're measuring the distance between that tester point and the surrounding points and taking a majority vote. And based on that majority vote, we label that new tester point. Okay? So what we need to do is we need to create a function that measures distance, all right? And the most traditional form of distance that we use in our day-to-day lives is Euclidean distance, all right? So we're going to basically define a method called Euclidean distance and have two inputs, 0.1 and 0.2. All right, Euclidean distance is that classic definition of distance you usually have in algebra, where it's the square root of y2 minus y1 squared plus x2 minus x1 squared. All right, so we're just going to be implementing that in code. All right, so we'll say distance equals numpy dot square root, we referenced previously numpy as np, and then the sum of 0.1 minus 0.2, and then we're going to square that. Okay, and then we need to make sure that the parentheses are right. Let me make sure that we have the right parentheses here. So 1 here, 1 here, 1 here, 1 here. I don't think we need this one. All right, so, and then we just need to return distance. So this is how the distance function works, and we're going to be needing this throughout the algorithm. So this is super important. Let me give you an example of how this might work. All right, so if you have some point A, okay, and A is some numpy array, that's the format of the inputs that this method will take because it's using NumPy functions. And it's a NumPy array 3 and 4, and then you have some point b. All right, we'll define this as b, and it's 5 and 9. All right, we want to measure the Euclidean distance between these 2 points. So we just print out the Euclidean distance between point A and point B. All right, and that turns out to be 7.0. Okay, does that make sense? You can go and look at, you can actually go and do the handwritten calculations, and you'll see that that does make sense. All right, so that's how distance works. Now let's get into the actual KNN algorithm. Now we're going to write the KNN method. So we need a function header like this, def KNN, and we're going to need some inputs. We're going to need our training data. We're going to need our X test data. We're going to need our Y train data, and we're going to need our Y test data. And finally, we're going to need some K value. All right. Now let's write the algorithm. So the predictions that we make, we need to store those predictions in a list. All right. So we're going to call the list where we store our predictions Y hat. All right. We're going to initialize that as an empty list. Now we need to iterate through every test point in the tester data and identify what class it belongs to. All right. So the way we iterate through it, through the tester data, is say for test point in x underscore test dot to numpy. So it's a numpy array. We can process it and use the distance function. We need to initialize a list called distances where we store all the distances from the test point to the points that we're going to be measuring. Then we're going to iterate through the training data to measure the test point to the distance from the test point to the training points. All right. So we'll say for I in range the length of x train, we will take the distance from that test point to every training data. And the way we do this in one line is we say distances, which is our distances list, dot append. Then we're going to take the Euclidean distance of the array format of x train at some indice, so dot iloc I, which means at some indice, and test point. Okay? So we are taking the distance between some train point and our test point and comparing them. All right? Then we need to use this distance data. We need to leverage it. So to manipulate and use this distance data, we need to turn it into a pandas data frame. All right? So we'll create a pandas data frame called distance data, and we'll say pd.dataframe. All right, and this takes a couple of arguments. The first one is data. So our data is distances. That's a distances list. And then we're going to label the columns. All right. Distance. We need single quotes here. And then the indices, we can just use ytrain.index. Okay. So now we have this distance data in a pandas data frame, which is super, super useful. Now what we need to do is we need to sort this distance data and get the 5 closest or k closest neighbors. 5 is just for the example. We need to sort this data and be able to select the n or k closest neighbors. All right. So we'll create another list. I know, k neighbors list. A lot of lists being used in this algorithm, but we need a lot of places to store our data. We need to create this list k neighbors list, and we need to say distance data dot sort values. All right, we're going to sort the values by distance. All right, we have our location argument, and then we need some indices to focus on. The indices that we're going to focus on are from 0 to our k value, right? From 0 to n. All right, so the n nearest neighbors. So if it was 5, it would be 0 to 5. Okay, finally, we need to find out the labels of these nearest neighbors. So we'll create a variable called labels, and we'll look at the y values for these neighbors. All right, so we'll say y train. Let's look at the y values for this k nearest neighbors list. That's what this little line of code means, right? Dot index. Okay, then what we need to do is look at all the labels for the nearest neighbors and say, this is the majority. Now, if you roll back the time and think about the time that you were learning about statistics in school, like in grade school, you know mean, median, range, mode. Mode is super important for this problem. Mode tells us what's the most common number, or what's the number with the most occurrences within some list, all right? That's really useful for our problem, so we're going to be using scipystats mode function to accomplish this. So we need to create another variable called voting, and we'll say mode of the labels dot mode. This is how we call it. All right. We need to take the most common label, which is 0. It'll be either 0 or 1, and then append it to our prediction, because really our prediction is either a 1 or a 0, right? So we'll say y hat dot append voting, and then all we have to do is just return y hat, and we're done. That is the KNN algorithm with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 lines of code using some external methods, library imports, data manipulation, but essentially it's just 12 lines of code. Super easy to implement. Now let's actually use this method and see what our results look like. Okay, so now what's left is literally using the KNN algorithm method we have created using the data that we already have. All right, so the first thing we need to do is split up our data into training and testing. All right, so we'll say x train, x test, y train, y test equals that scikit-learn method train test split, and our inputs will be x and y. Now I'll explain these two variables, test size and random state. What do test size and random state mean? So test size means the train test split. All right, so if test size is set to 0.3, that means that 30% of the data will be allocated to testing and 70% of the data will be allocated to training. Now, you want to have the model learn, and that's what training data is for, but you also want to validate that that learning actually works with testing data. It's really important that you find a good train-test split. If you have too much testing data, you're not going to give the algorithm enough time to learn. And if you have too much training data, you're not going to have enough data to validate that your algorithm actually learned. So the split is super important. Train-test split is crucial. All right, and the random state is just some random way that the train test split is going to split the data into 70-30. This is just a seed that you can use to reproduce that random split. Now, the final thing we need to do is create some variable that will hold the y hat outputs for our KNN call. So we'll call that y hat test. We'll say KNN, and then our inputs, x train, x test, y train, y test, and then our k value. And we're going to set our k value to, I don't know, 5. Never set your k value to an even number. Why? Because if it's an even number, then the vote will tie sometimes. And if the vote ties, nothing, like the output's going to be wrong most of the time if the vote's always tied. So it needs to be an odd number, so one number wins. All right, we're just going to set it to 5 for now. Now if we run this, oops, we didn't run the previous cells. Let me just run all. Okay, so now we have successfully implemented KNN. Let's look at our accuracy, all right? And we can test different k-values to see what k-value will lead to the highest accuracy. How do we do this? Pretty simple. We create a list called accuracy values where we'll store all the values of our KNN model's accuracy, okay? And then we just need to use simple iteration for I in range 1 to, let's say, 10, or even 15 for a larger sample size. We'll use y-hat test. We'll use the same definition as we did previously, but k-value will equal to I, all right? And then we'll store our accuracy in accuracy vals by saying append, and then we actually need to use the accuracy score functionality that we imported from scikit-learn, and we input y-test and y-hat test, all right? And that's basically a method that will look at two lists and say, okay, this list has certain discrepancies, so the accuracy is X. It's 0.89 or 0.73 or 0.62, whatever, a value between 0 and 1. All right? And so that will yield our accuracy. Now, we just want to plot this accuracy to see what value yields the highest accuracy. So we'll say plt.plot, and then we need a range for the k-values. So we'll say range from 1 to 15, just like we said. We're plotting our accuracy vals list. We can set some cool formatting stuff like the color of the lines, the marker. We'll set it to X, and even line style is an option. We'll say dashed. All right, now if we plot this, might take a minute, it's going to plot every accuracy value for the KNN model with every k value from 1 to 15. All right, and so this is going to show us based on different k values what accuracy we're going to yield. All right, so here we have our graph, and we can see clearly that the highest accuracy is yielded when we have a k-value of 5. So I actually predicted correctly. A k-value of 5 will lead to an accuracy of about 82%, I'm guessing, from what I see on this graph. So let's finally implement that KNN algorithm with the perfect k-value, or the highest accuracy k-value at least. So we'll use the same variable name, y-hat test. We'll set it to KNN, and we can just use this, what we wrote previously, set k equal to 5. Then we'll print that accuracy score, again, using just code reusability. That accuracy score, all right? And then what we're going to do is, we are going to label the points blue or orange based on if the consumer did purchase the iPhone or they didn't, to see if our model actually did a good job, all right? So we'll say for I in range, the length of y-hat test, because we're going through the entire length of y-hat test. If y-hat test indice I equals 0, then we will plot a point, all right? And we have to say at a given indice in X test for age, and that same format for salary, all right? And then if it's 0, we need to set the color equal to blue. We're almost at the results here, guys. And then this same format, but just we need to change this to 1 and this to orange. Okay, and that's that. And just want to make the plot look nice, so we can say plot.style.use ggplot. There are a bunch of different formats you can use. This is the one I'm just choosing for today. And then we'll label the X and Y axes. So the X is obviously age. The Y is salary. Let me just change this. That's a mistake. And the title we will call KNN results. We're done! Congratulations. Now let's see what the output of our model is. Here we go. We're running the moment of truth. So our accuracy is about 81%. These are the results of our KNN algorithm. So visually, this is what the KNN algorithm predicted for our testing data. Now, let's actually plot what our testing data looks like and compare the two. Alright, so I've reformatted our KNN results to make it look like a Seaborn style. Let me tell you why. I want to compare what our KNN algorithm outputted versus what the actual data tells us, like what the actual data looks like. So to visualize this, we just need to write sns.scatterplot using our data set, setting x as xtest age, setting y as xtest salary, and setting the hue or the color of our data points as whether the user purchased the iPhone or not. Now, this is our output. So if you take a look, generally, our algorithm did really well. I mean, the accuracy was 81%. And if you look at this, there are some discrepancies at the bottom right here towards the older customers. But generally, the output is very similar. Where you learned how to write the KNN algorithm from scratch, make sure to leave a like down below and subscribe. It greatly helps with the growth of the channel. Thank you so much for watching, and I hope you have a good day. Peace.